Frame 3I Atlas as a cosmic message in a bottle containing frozen water that's potentially 3 billion years older than our entire solar system. This angle taps into profound existential wonder. The comet carries ice formed when our sun didn't even exist yet, during the galaxy's cosmic noon, when everything was young and chaotic. The emotional hook? This water has been frozen, unchanged, traveling through the darkness for longer than Earth has existed. It remembers a galaxy we can never see. Why it works? People connect emotionally with tangible concepts like ancient water more than abstract chemistry. The timescale is almost incomprehensible, which creates that spine-tingling sense of cosmic insignificance that drives shares. 3I Atlas, an interstellar comet that just did something so strange that astronomers are still trying to figure out what they witnessed. This thing turned red, then green, then blue. Comets don't do that. They're supposed to get redder as they approach the sun, not bluer. But that's just the beginning of the weirdness. This comet is leaking nickel without iron. It's packed with carbon dioxide instead of water. It appeared exactly behind the sun when it reached peak activity, almost like it knew where our blind spot was. And here's the part that's going to blow your mind. It might be 3 billion years older than Earth itself. Stay with me, because what I'm about to show you gets way stranger. So here's what we're dealing with. On July 1st, 2025, astronomers spotted something moving through space at 130,000 miles per hour. At first, they thought it was just another comet. But then the data started coming back, and nothing made sense. Every time scientists analyzed this thing, they found something that contradicted what they knew about comets. The chemistry was wrong, the trajectory was too perfect, the timing was too convenient. And the more spacecraft we sent to observe it, the more questions we had. See, we've only ever confirmed 3 interstellar objects passing through our solar system. The first one was Oumuamua back in 2017, which caused a massive debate because of its weird cigar shape and the way it accelerated. The second was Borisov in 2019, which actually behaved like a normal comet and calmed everyone down. But 3I Atlas? This one makes Oumuamua look ordinary. Because unlike those other 2 visitors, 3I Atlas doesn't come from a nearby star system. The statistics suggest it comes from the thick disk of our galaxy. That's the realm of ancient stars that formed when the Milky Way was young and chaotic, somewhere between 7 and 14 billion years ago. Think about that for a second. Our sun is 4.6 billion years old. Our entire solar system, Earth, everything we've ever known, is 4.6 billion years old. This comet could be 3 billion years older than that. It existed before our sun was even born. And now it's here, passing through our neighborhood, and scientists are scrambling to study it before it disappears forever. Let me walk you through what makes this comet so absolutely bizarre, and I'm going to start with something that has chemists completely baffled. When telescopes at the Very Large Telescope in Chile pointed at 3I Atlas, they detected nickel vapor coming off the comet. Now, finding metals in comets isn't that weird by itself, but here's the problem. They found nickel without any iron. That should be impossible. Nickel and iron are created together in supernova explosions. They're basically twins. They always appear together in space rocks. Always. Finding one without the other is like finding a person with a left hand but no right hand. It just doesn't happen in nature. And it gets weirder. The comet was releasing this nickel when it was 3.88 astronomical units from the sun. At that distance, space is freezing cold, way too cold for solid metal to just evaporate into gas. For nickel to sublimate directly from solid to gas, you need temperatures that just don't exist out there. So scientists came up with a theory. Maybe the nickel is bound up in something called nickel carbonyl. This is an extremely rare and volatile compound that can release nickel atoms at much lower temperatures. The thing is, nickel carbonyl is so unusual in natural space environments that finding it would be almost as surprising as finding the nickel by itself. And the rate at which this comet was producing nickel? 5 grams per second, increasing exponentially as it got closer to the sun. The production scaled with a power law exponent of about 9. That means for each step closer to the sun, the nickel output increased nearly a billionfold. No one has ever seen that kind of scaling in a natural comet before. But wait, because the chemistry gets even more impossible. Most comets are basically dirty snowballs. They're mostly water ice with some other stuff mixed in. When you analyze a typical comet, you'll find maybe 80% water, some carbon dioxide, a bit of carbon monoxide, and other ices. 3I Atlas is completely backwards. The James Webb Space Telescope and SPHEREx analyzed this comet's composition and found it's 87% carbon dioxide by mass. 87%. Only 4% water and 9% carbon monoxide. The ratio of carbon dioxide to water is 8:1. In a normal comet, water dominates by far. This is the highest carbon dioxide to water ratio ever recorded in any comet, anywhere. And nobody knows how a comet like this could form. What kind of stellar system creates a comet that's basically the opposite of everything we've ever seen? Now let me tell you about the color changes, because this is where things start feeling less like science and more like watching a magic trick. When 3I Atlas was first discovered in July 2025, it had a reddish tint. That makes sense. Lots of comets have reddish surfaces because of organic compounds that have been baked by cosmic radiation for billions of years. But as it got closer to the sun through August and early September, something changed. By September 7th, the comet turned bright green, and I mean really green, vibrant, glowing green that you could see even with amateur telescopes. That green color comes from a molecule called cyanogen. It's a deadly compound, basically cyanide bound up with carbon. When sunlight hits cyanogen molecules in the comet's atmosphere, they glow green, beautiful and terrifying at the same time. The cyanogen production increased dramatically, scaling up by a factor of 10 for every step closer to the sun. The comet was becoming this toxic green beacon in space. But then came October 29, 2025, perihelion, the closest point to the sun. And 3I Atlas turned blue. Not just a little blue, bluer than the sun itself. Space-based coronagraphs watching the comet recorded this transformation, and scientists are still trying to figure out how it happened. See, when comets get close to the sun, they're supposed to get redder. The dust particles they release scatter light in a way that makes them look more orange or red. That's basic physics. But 3I Atlas did the opposite. The blue color suggests the comet was emitting ionized gases or experiencing some kind of energetic chemical process that overpowered the normal dust scattering. Maybe ionized carbon monoxide, maybe something else entirely. But whatever it was, it made the comet glow blue in a way that contradicts everything we thought we knew about cometary behavior. Red, green, blue, like a cosmic traffic light cycling through colors that shouldn't be possible. And the brightness? The comet brightened at a rate that scaled with distance to the power of -7.5. That's roughly twice as fast as typical comets brighten. Everything about this object was operating in overdrive. But here's something that I haven't told you yet, and it might be the strangest detail of all. In July 2025, the Hubble Space Telescope observed 3I Atlas and saw something that made no sense. The comet had a tail pointing toward the sun instead of away from it. Think about that. Comet tails are supposed to point away from the sun because the solar wind pushes them. That's like Comet 101. But 3I Atlas had this anti-tail extending sunward, almost like it was being pulled toward the star instead of pushed away. Now, scientists have explanations for anti-tails. Sometimes it's an optical illusion caused by viewing angle. Sometimes it's large dust particles that don't get blown away as easily. But this anti-tail was different. It suggested active outgassing on the day side of the nucleus, maybe driven by that weird carbon dioxide composition. As the comet got closer to the sun, the anti-tail gradually transitioned to a normal tail. But for a while there, it looked like the comet was moving backwards, pulling material toward the sun rather than away from it. One speculative paper even noted that this positioning and behavior would theoretically be optimal for an extraterrestrial spacecraft conducting a clandestine reverse solar Oberth maneuver, basically using the sun's gravity to slow down and become captured by our solar system. Now, before you get too excited, scientists are very clear that this is just a thought experiment. The overwhelming evidence points to 3I Atlas being a natural comet. But the fact that researchers even mentioned this scenario in a paper tells you how unusual the geometry and timing really were. Speaking of timing, let me tell you about the coincidences that have made some people raise their eyebrows. 3I Atlas's orbit is tilted only 4.886 degrees from the solar system's ecliptic plane. For context, the ecliptic is basically the flat disk where all the planets orbit. Most objects in space have random tilts. The probability of an interstellar object arriving with such a flat trajectory is about 0.2%. That's 1 in 500. But it gets more specific. This nearly flat orbit brought 3I Atlas remarkably close to multiple planets. It passed 0.19 AU from Mars on October 3rd. That's about 28 million kilometers. Then 0.65 AU from Venus on November 3rd. And it will pass 0.36 AU from Jupiter on March 16, 2026. The combined probability of these close approaches? Less than 0.005%. That's 5 in 100,000. Now, rare events do happen. That's how statistics work. And we're observing this object precisely because its trajectory brought it through the inner solar system where our telescopes can actually detect it. So there's a selection bias at play. But you have to admit the odds are pretty wild. And then there's the timing of perihelion itself. When 3I Atlas reached its closest point to the sun on October 29, 2025, it was positioned almost directly behind the sun from Earth's perspective. Solar elongation of only 12.8 degrees. This meant that during the exact moment when the comet was at peak activity, when it was turning blue, when it was brightest, when all the weird chemistry was maxing out, Earth-based telescopes couldn't see it. It was hidden in the sun's glare for weeks. The comet reached its most interesting phase right in our blind spot. Coincidence? Almost certainly. But it's the kind of coincidence that makes you pause for just a second and wonder. Fortunately, we had spacecraft positioned throughout the solar system that could observe what Earth couldn't see. NASA's Psyche spacecraft passed within 0.302 AU of 3I Atlas on September 4th while traveling to study a metal-rich asteroid. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter watched the comet during its closest approach to Mars on October 3rd, using their high-resolution cameras and spectrometers to capture detailed data. But here's the really cool part. Both NASA's Europa Clipper and ESA's Hera spacecraft passed through the predicted path of 3I Atlas's ion tail between October 25th and November 6th. These spacecraft have magnetometers and plasma instruments designed for studying other things, but they were able to directly sample particles from the comet's tail. Think about what that means. These spacecraft collected actual atoms and molecules that formed in another star system billions of years ago. Material that predates our sun, traveling through space for eons, and we flew through it and measured it. That's not just cool science, that's touching ancient history. Now let me tell you about the nucleus itself, because even the comet's core has mysteries. Observations showed that 3I Atlas has a rotation period of about 16.1 hours. That's pretty slow for a comet. The light curve amplitude is only about 0.3 magnitudes, which suggests the nucleus is either nearly spherical or it's tumbling in a complex way. Despite all the intense outgassing, all that nickel vapor, all that carbon dioxide, all those color-changing chemicals, the rotation period stayed stable. That tells us the nucleus is massive and solid enough to resist the torque from gas jets shooting off its surface. It's not a rubble pile. It's not a loosely bound collection of ice and dust that would have spun apart by now. This comet has structural integrity, which is interesting for something that's potentially 14 billion years old. The size estimates range from 0.32 to 5.6 kilometers in diameter, though most analysis suggests it's under 1 kilometer based on Hubble observations. Small but mighty, releasing enormous amounts of material for its size. And speaking of material, despite having very little water compared to carbon dioxide, 3I Atlas still has water ice. Gemini South and NASA's Infrared Telescope facility detected water ice grains in the coma through spectroscopic analysis. The ice appears to exist as large grains mixed with dark carbonaceous material. Maybe 30 to 37% water ice by cross-sectional area, mixed with 63 to 70% amorphous carbon, or materials similar to the Tagish Lake meteorite. NASA's Neil Gehrels Swift Observatory measured the water production rate at 1.36 times 10 to the 27th molecules per second at a distance of 2.9 AU. That's about 40 kilograms per second of water. Pretty high activity for being that far from the sun. So this comet has water, just not as much as normal comets. And that water could be some of the oldest frozen water ever observed. Water that formed in another planetary system, around another star, during an era we call cosmic noon, when the Milky Way was young and star formation was happening at incredible rates. Pre-discovery observations from the Zwicky Transient Facility showed that 3I Atlas was active out to at least 6.5 AU from the Sun. Some analysis suggests it started producing steady dust outflow around 9 AU, which is when carbon dioxide ice begins to sublimate in deep space. That distant activity confirms what the composition told us. This comet is driven by carbon dioxide, not water. It woke up early in its approach because CO2 is much more volatile than water ice. So here's where we are. We have a comet that's potentially 3 billion years older than Earth, coming from the ancient thick disk of the Milky Way. It has impossible chemistry, nickel without iron, carbon dioxide dominating over water, production rates that scale like nothing we've seen before. It turned red, then green, then blue. It had an anti-tail pointing the wrong direction. It arrived on a nearly flat trajectory that brought it close to multiple planets. And it reached peak activity hidden directly behind the Sun at the exact moment Earth couldn't observe it. The probability of all these things happening together? Astronomically low. And yet, here's what I need you to understand. Despite all of this, despite the cascade of impossible features, the overwhelming scientific consensus is that 3I Atlas is a natural comet. Physicist Brian Cox put it plainly. It's a comet made of carbon dioxide and water ices, not a starship. NASA scientists have emphasized that all available evidence overwhelmingly points to a natural origin. The object exhibits all the hallmarks of cometary behavior. It has a resolved coma, dust production consistent with sublimation physics, spectroscopic signatures matching icy volatiles, light curve behavior typical of rotating nuclei. Its unusual features likely reflect its extraordinary age and unique formation environment. It formed around a different star, in a different part of the galaxy, during a different era when the chemical composition of the universe was different. That's what makes it so valuable. 3I Atlas is a messenger from cosmic noon, carrying materials and information about planetary formation conditions that existed 9 to 13 billion years ago. Before our Sun, before our solar system, before Earth.
The ice in this comet could be older than any material we've ever directly studied. The organic compounds baked into its surface have been exposed to cosmic radiation for billions of years longer than anything in our solar system. This isn't just a comet, it's a time capsule from the ancient Milky Way.
3I Atlas will return to visibility from Earth in early December 2025 as it emerges from behind the Sun. Its closest approach to our planet happens on December 19, 2025, at a distance of 1.8 AU, about 270 million kilometers away. That's completely safe, no danger whatsoever, but it's close enough for detailed observations with ground-based telescopes, Hubble, and James Webb throughout December. After that, the comet continues its journey outward. It passes Jupiter in March 2026, and then it leaves our solar system forever. Back to interstellar space, back to wandering the galaxy for another few billion years. We got lucky. With modern telescopes, a fleet of spacecraft positioned throughout the solar system, and timing that brought this ancient visitor through our neighborhood, humanity captured unprecedented data about this cosmic messenger. The observations gathered during its brief passage will inform our understanding of planetary formation not just around our sun, but across the entire galaxy throughout cosmic history. We're learning about star systems that existed before ours, chemical processes that occurred in a younger universe, and materials that have survived longer than we can fully comprehend. This represents only the third confirmed interstellar object we've ever detected passing through our solar system. And it's the first one traced to the galaxy's ancient thick disk. We live in a galaxy filled with billions of years old remnants from the dawn of cosmic time. Occasionally, one passes through our neighborhood as a reminder of the universe's immense age and complexity. 3I Atlas is that reminder, an impossible comet that challenges what we thought we knew, carrying secrets from an era we can only study through visitors like this. And in a few weeks, if you look up at the night sky in December, you'll be able to see it with a good telescope. A speck of light that's older than our world, briefly visible before disappearing forever into the darkness between stars. If you want to see what happens when we actually try to visit an interstellar object, watch this next video.